Sure. So, as I said, the context for this was in figuring out what's the reality, what people actually do with what I would define as big data technologies, big data approaches, and how it's used for security. Because the amount of hype that was observed, the amount of, if you read, Computer World or whatever other publication, it would seem like everybody and their monkey has a Hadoop cluster full of security data, and they keep running, machine learning algorithms on it before their morning coffee. And then you try to actually find some of those people, and you find people from Zion's Bank, of course, and then you find, well, almost nobody else. So the funny part is, I wanted to figure out what's the operational reality, what's real, what's not. So any talk about reality must start from definitions, and lots of discussions about defining big data go quickly into a rat hole. So I still like to stick to the high variety, high velocity, high volume data, which is what a particular analyst at Gartner coined as 3 Vs. And I want to stay away from defining any kind of security analytics, because this is going to get hijacked by the vendors pretty quickly, if not already been hijacked. So I stick to this for my research, from this effort. I wanted to simply explore how people use big data tools, such as Hadoop, not exclusively Hadoop, and analytic approaches, such as hypothesis testing, some other statistical methods for security. So as a result, I wanted to stick to substantial parts, avoid any kind of marketing, hype, and things of that sort, and focus on both the size, the bigness, as well as on the analytics part, not just on the, I have this pile of data that nobody knows what to do with. So this was my initial research goal, initial research scope. Find out what's the reality with this today. And this is your example of Excel. This is a survey done by, okay, fine, one publication that says, which of these big data tools are in use at your organization? And the first one is Excel, of course. By far the most popular at 65%. Now, I've seen, this is one example that's probably the most blatant. I've seen more incredible examples. And to me, I explain them like this. If somebody would ask me, what way of getting from A to B would I prefer? Walking from A to B, taking a car from A to B, or magically being transported via teleportation from A to B? I would obviously say, I'd rather be teleported. And so this doesn't mean I do it every day or at all, but some of the surveys say, would you like to use broken, crappy product X or big data analytics for security? And people say, oh yeah, totally. I want to use this futuristic big data stuff. And some of the surveys have resulted in perception that everybody is doing it. Other people simply broaden the definition to when it becomes kind of idiotic, including Excel, including, I think Microsoft Access, for some strange reason, isn't on the list. And that makes me somewhat worried, because if Excel is a big data tool, then Access is most definitely a big data tool. So this type of stuff is what we have to deal with occasionally when we try to figure out what's the reality. So lots of vendors also poison this mind sphere by saying that they have security analytics tools for sale, and it may be literally anything. It may be security information management, it may be log management, it may be search. And this exists in many minds, but it doesn't really exist in reality. We are talking about something that you can practice, you can do. You can analyze the data if you have the data and the tools and the brain power to do it, but there's no box you can buy that would do it. There's no subscription with a SaaS vendor or a box that magically would make you big data security enabled. But that's kind of a side comment. So what's the reality? I mean, the way we discover reality, at least in our team, is we talk to people who actually do it operationally, either people who build such systems, or people who operate systems, or people who are in late stages of exploring and deploying whatever they can build around data analysis. So when I say what I mean by this is plenty of a few organizations actually collect pretty massive volumes of data. I've spoken to a few that are well into petabytes, And as I sometimes say, everything is hard in petabyte scale. Even copying a file from one machine to another machine is hard. And then their scope of data expands much beyond logs, much beyond Windows, Unix, network device logs, but into all sorts of other types of data, including an extended list of context. So somebody, I'll get to more examples, but there was one company that had about 60 gigabytes of web proxy data a day. And they wanted to, which isn't that much as far as web proxies are concerned, but what they wanted to do is they wanted to enrich all the proxy data for every IP address with IP, with a DNS name, whois, geo, as well as all the pages that the person downloaded when they surfed through a proxy. That would push you from the mere 60 gigs a day well into low terabytes or even high terabytes. So their analytic approach wasn't in using a commercial product like a SIM. They had to build something that can, in fact, fuse 60 gigs of log data with another terabytes of context data. In their case, they wanted to do profiling on the geo, do some analysis of DNS names, again, random domains, the usual stuff, as well as broader context about who registered stuff when, and so on all the IPs. That called for something that you cannot go and buy at the store. You have to pretty much build the system yourself. Now, for this audience, I'll probably stick to a very minimum motivational context, but I also wanted to explore what made those companies that actually built their clusters, that built their massive systems that included either data scientists or they learned statistics to do the analysis. What motivated them? Now, the interesting part about the motivation is that many of those organizations had commercial tools. Security information and event management tools, collect logs, provide correlation, do reports. And some of these organizations simply outgrew what the tool can do. Again, the example with web proxy logs, you've seen those either blue coat logs or some other types of web proxies, Squid, whatever. These are pretty voluminous, but if you try to enrich the data, you get pushed way into much higher scale. So you cannot simply load up a commercial tool. Certainly you can put them in Splunk after paying quite a lot of money to Splunk and then search. But as far as working with the data, you get search, you get some other analytics, and then many of the tasks will be on you. And then there's this one group of company that wanted to utilize one cluster for all sorts of data, starting from transaction logs, application transactions, financial data from applications, and IT data. These are rare, but these exist. And in these companies, the fraud team, the IT ops, as well as security team use the same repository. These cases are rare, but that was an interesting case to me because this is where they utilized the whole bigness of data and also multiple types of analysis. To me, that was the most interesting. Quite a few had simply outgrown their tools by size. They wanted to load up more data than was economically possible or was technically possible. So this is one example that's how it was built, which is, let's put it this way, inspired by a real story. I altered a couple of details. So this was a large, I think it was a manufacturing company, but details are separate, which had a security information tool from a highly rated vendor. But they realized that they want to load more data in there. They wanted to have full network session captures. They wanted to get all the flows. They wanted to get some of the content they capture. So what they built is a system that fed regular logs into SIM and also fed it into Hadoop for long-term storage in a normalized format. They also fed some data directly into Hadoop. They loaded, again, geo, some of the whois info, some of the other context, as well as full network session data. Not packets, because they decoded packets into sessions and then loaded sessions into Hadoop. And then the data was cross-referenced from the SIM tool into Hadoop. So they had one repository for everything they captured. And then, as you can imagine, data access became a bit of a challenge because they had name-value pairs, essentially in Hadoop, and then they had to extract them and, for example, visualize or do more analytics, even summarization. So they structured data selectively, loaded some of it into Mongo, some of it into Postgres, because some of their tools didn't support Mongo, I think. And then they also run full text index search on Hadoop. So this is an interesting situation, because if somebody needed to do search, they would go to Solr and search across all the nodes. And if somebody wanted to see a pretty picture or do data exploration, more of a structured data, they would get data from one of the structured data storage formats. And then on the process side, this company the security team borrowed a statistician from a business unit where he was involved with more marketing type research. So this to me emerges one of the themes in this effort, because obviously the InfoSec team or IT wouldn't have many statisticians and stuff, but some of the business units do, and occasionally people are able to borrow them and use them for that type of analysis. So this whole effort took about 5 years of work at this company to arrive at that state, so that they have low petabyte total storage, 1 or 2, I don't remember the exact scale. They retain the use of their security information tool for more tactical things, for more sort of from week to months type of time frame, and then they loaded the rest of the data, indexed it, selectively structured it, and then this whole system was built. Again, 5 years of work, and they really like the system. There's nothing of that sort you can buy from the vendor. This is a sort of a rough diagram how their data flows between their security information event management, which kind of wakes up people at 3 a.m. if there's something immediately actionable. And then context, historical data goes into Hadoop. They run data discovery, and if they're lucky, they occasionally run predictive type of analytics. They sort of get into that state at this point. In this case, again, this is probably more of a marketecture than architecture, but the logic is that they haven't thrown away the tool they had. They simply used the security information management tool for what it's meant to be used, more of a short-term analysis, and then they had the whole multi-year retention, broader scope of data in Hadoop. Now, this here, well, it wasn't a relational database in their case, but it was relational-like storage. So anybody who knows SQL can get the data out. Getting data out of Hadoop would either involve index search or data that's pre-structured and then picked from, don't remember what exactly they used. The result is the system that's used by multiple teams, and that makes them pretty happy. Now, I've spoken to a few organizations of the same sort, and I tried to extract some of the lessons. What made those people actually succeed with a fairly massive effort, large data volume, different type of data access methods, different type of architecture compared to relational databases. And the surprising part wasn't that there are specific algorithms or specific things they used, like, oh, we used clustering, oh, we used unsupervised learning. The most common theme was that the mindset wasn't about where do we buy the system. The mindset was more of the how do we explore the data. Most of those organizations also had extensive experience with network forensics, SIEM, network behavioral anomaly detection, or some other productized or more product-based tools that you can buy. The thing is, they didn't just magically become security data scientists. They started with the tools, and they pushed many of these tools to the wall. And then they said, okay, you know what? We got to build something of our own. And fortunately, there are pieces like Hadoop, like Mongo, like other components that they can reuse. They didn't start thinking, hey, let's do big data. They started doing small data, pushed it to the wall, and then kind of graduated to the next level. The surprising part was that the mindset emerged in all of the conversations. Now, I work for Gartner, and we deal with all sorts of enterprises at different maturity levels. I was trying to tell somebody about big data, and he stopped me and said, you know what? We have trouble patching Windows. Don't talk to us about big data. Our main problem is that our Windows patching lifecycle is 90 days. And I'm like, okay, let's talk about Windows patching. Fine. But the state of maturity at some organizations is nowhere near being ready for usage of Hadoop, statistics, whatever other methods. Moreover, lots of companies wanted to buy it in a boxed format. There's plenty of calls I handle at Gartner where people say, I read this that I need to buy this big data analytics tool. Where do I buy that? And then this way to start, well, first thing is there's nothing to buy. And the second is, this is what was reported to be the easiest way to not succeed with this. The opposite, trying to have the data you have, explore it, figure out what to do with it, what answers you can extract. Maybe you can torture the data you have and get the answers, as opposed to buy a box that gives you answers. This is obvious for a lot of people, but what's not obvious to the same people is that there's a lot of people for whom it's not obvious. Lots of people want to buy boxes. They want to have a tool that gathers all the data, all the petabytes, and just spits out what you need to do next in your daily routine. We are nowhere near, no, forget the nowhere near. We will never be anywhere near that, because security is just too tricky as a space. So as far as people who would do this, this is a pretty much a no-brainer, but the brainy part the brainy part here is that you can find people, obviously, who know security. You can find people who sort of understand the basics of Hadoop programming with some challenges. But finding a person who is also understands statistics, I don't know, master level, not necessarily a PhD, is what stumps many of those projects. People say, we're going to do big data. We have a person who knows how to investigate incidents, obviously the skill sets of most enterprise security teams. We have people who know we can borrow a Java programmer who can do MapReduce, but finding somebody who would be able to test algorithms on data and say, you know, this method works really well, this method, not so good for this goal, for this type of data. That's what ends up being challenging. And yes, there are some organizations that are trying to have it in one person. That's very unlikely. Typically, we talk about a shared pool of people, essentially borrowing Java programmers from development, borrowing statisticians from some BU, and then pairing them, or I guess tripling them in this case, with a person who knows what's malware, how to deal with threats and stuff like that. So this is how it worked at those organizations. What else I wanted to do is I tried to essentially structure or taxonomize the cases I've seen so that I can provide guidance to other companies who are trying to do this. And I kind of came up with about 4 distinct scenarios. One of them simply goes like this. An organization gets a certain off-the-shelf tool, whether it's security information management, network forensics, or whatever else, and then they push it to the wall. The volume goes into much higher levels, and they hit either an economic wall, they cannot pay anymore to the vendor, or they hit a physical wall. The system doesn't structure, doesn't go, or becomes very slow. So they toss the whole long-term retention and replace it with their own cluster with whatever technology. Well, it was Hadoop in most cases, it was HPCC in one more case, and it was whatever other distributed storage technology. And then where this organization ends up is a case where they have a large pile of data stored into a cluster. And I know of quite a few people at these organizations who sit now and stare at their Hadoop clusters because the data they piled in there is not structured. They're still thinking about how to do index search. So in essence, they ended up with a big data collection. They have the bigness, but they don't yet have the analytics. This is a route that may eventually get them to extracting value out of data, but then again, it may not. So I wouldn't say it's the good route, but I can't say it's the bad route either. But there are some companies who are kind of stuck in this position of, yeah, we have a cluster. Well, what's in the cluster? Well, there's 242 terabytes of data. Okay, what does it mean? Oh, we don't know. Well, how would we know? Well, we don't know even how we would know. And then it's kind of, okay, what do we do next? Still, this does mean that they're not looking for a vendor to do it for them. They're still trying to slowly explore the data they have. Here's another scenario that I observed. This is what I call kind of a variety explosion, where an organization gets whatever commercial tool, it might be SIEM, it might be a log search tool, it might be something else. And they start loading all sorts of strange types of data in there. I've seen some people who are trying to Splunk configuration records or whatever it was. So the point is that some of the tools work well for logs and for flows, but they don't work for other types of data. Chat logs, certain types of application records. So the types of, and I've seen a couple of organizations that wanted to do automated text analysis of their IM logs, obviously in financial industry, where they wanted to have kind of analytics on the IM chat. They wanted to collect all the data, but clearly a SIM tool or a network forensics tool isn't the right answer. So they started being a cluster where they can pile all the data and slowly link it to each other, so that they have not just a pile of data, but a fairly well interlinked pile of data. In one case, I've seen organizations even trying to use a graph database, which goes a little bit outside of my comfort zone to understand how they did it. But the logic is that they want to have one place for so many types of data so that nothing off the shelf worked for them. This route ends up being somewhat more successful. There are more organizations that actually make meaningful use of this data, despite the number of types and despite the high variety. Another interesting scenario is where company simply wants to have search at a very high scale. Now, Elasticsearch or other types of technologies or commercial tools like Splunk are obviously quite useful. And there are situations where the data volume grows well into high terabytes, and in a very few cases I've seen to low petabytes of total data. In this case, despite the fact that they do search, and I don't really think search qualifies as analytics. I mean, if you're an optimist, search qualifies maybe as a gateway drug to analytics, but it isn't analytics. If you type root and you get 5 million rows back, you haven't really analyzed anything. Or if you type a username and get whatever number of rows back. But search does end up being a route to start in the data. I've seen one company that actually threw most of their efforts into text mining the data in their storage. So they had Elasticsearch run across the cluster, and then they try to do a text mining on the data, log data, proxy records, not sure about other types of data. But the logic is that they go approach the big data goals through search. The interesting bit about this is that getting from being able to search quickly to being able to explore data at large scale is also not trivial. You end up with an effective search tool, but you may end up with an ineffective tool that gives you visibility, situational awareness, whatever else. So this is one route, and I've seen some organizations that go in that way, but it's also full of a fair number of pitfalls. And by the way, I won't suddenly arrive at one way and say, everybody do that, that's the right way. I'm describing a field where a lot of research is still incomplete, and a lot of companies are still in the, here's how it's hard, we don't know how to do it right. So there would be no magic revelation at the end. There would be some recommendations, but there wouldn't be kind of, here's one way we discovered the truth. And then there's one case where, I really went overboard with the transition visuals, I think. So this case is an organization which also started from commercial tool, but then okay, I did go overboard. Fine, it's official. It's big data made me do it. Yes, exactly. And this organization actually outgrew their commercial tools to the extent that they simply threw them out. They ended up rewriting most of the functionality of a commercial tool, which is another heavy-duty effort because you need to convert text data to fairly normalized formats. A lot of things that SIM vendors, like well-known SIM vendors, charge money for, has to be done manually, essentially by rows of people who convert your syslog, your Windows event logs, to normalized fields. This organization really wanted to do more analysis that their SIM was able to do. So what they did is they rewrote it. They rewrote it based on Hadoop as a backend. The interesting bit about this is because their experience was, again, also took a few years, they ended up with a tool that, to my understanding, exceeds the analytic qualities of most of the SIM tools currently on the market. So the case is they build a system that's better than what the vendors sell. it's a very painful road. Obviously, an organization did have plenty of development as well as research resources to do it, but they did pull it off. They're very happy with the system, and now they end up with this whole single warehouse model for security, network security, endpoint security, trying to monitor for insider activities as well as fraud. We're very happy with the system. Again, took years to build, and whenever vendors show up at their back door, they kind of go play this game. Hey, vendor, show me yours and we will show you ours. And the vendor shows their tool, talk about correlation, reports, and then this team shows them their tool and theirs is better. No sale. Now, at this point, it's pretty clear what are some of the problems that organizations are facing. I don't want to dwell on the challenges. I kind of get too excited about explaining how some things are hard. But the point is that if people read the security media or IT media and they think, hey, we're going to go do big data, there would be plenty of hurdles all the way down to the fact that data access, large-scale data management, statistics expertise isn't very obviously available. And there's nobody to buy it from. So what are some of the things you can't do? By the way, because I work for Gartner, I had to insert what we call a SPA, strategic planning assumption, that is meant to really discourage people to casual about big data. So if you need some extra negative motivation to show to your boss who's about to give $1 million to a particular vendor who promises big data, you can probably throw this one at him. The funny part is this is ultimately a domain of 99% versus 1%. Remember the title of the talk. In the SPA, in the planning assumption or prediction, we do say that most organizations simply won't be able to ride the wave. We might say that, yeah, big data analytics is a big deal, there's plenty of security data, but making use of it would remain the domain of people who are really dedicated or truly adventurous or have unique needs or unique resources. There are certainly financial organizations, there are certainly defense contractors, there are obviously e-commerce companies that excel at this game. But spreading that knowledge to a more normal, more traditional company is becoming is really difficult. However, what are some of the ways to start? You know what, let me reorganize it a tiny bit. So, because this is so new, I wish I can give you, top 5 recommendations that we learned. I did share some of the case studies, or abstracted case studies. I did share some of the lessons learned. But there's nothing that I would qualify as best practices. When people talk about best practices, it implies that there's some kind of a state of practice that's been practiced for a while, and then certain things drop out at the bottom and they're bad practices, and certain things pop up at the top and they're best practices. In this case, we haven't practiced it enough to know that they're best practices. This is all pretty experimental. This is all kind of trial and error. And so call in anybody and asking what are the best practices for big data used for security should produce no answer. If somebody has an answer, likely that's the best practices they made up. Still, I wanted to draw some lessons from this and then point a couple of ways forward for your organizations, for people who want to do and try something. The discussion of a mindset led me to say that I wouldn't recommend any massive data collection efforts. No building clusters, no multi-terabyte data collections. It's probably more useful to explore the data that's already sitting in your packet captures and your SIM tools, into your log management tools, or even in that old syslog server you built in 1997 before your morning coffee in one bad day. There's data there, and trying to figure out what to do with it, how to analyze it, whether to index it, whether to structure it, is more useful than building a Hadoop cluster. Because we observed some organizations that are stuck in big data collection and with no obvious way forward to making sense of the data, we want to produce this word of caution that trying to quickly scale to large volume collection without scaling any of the analysis is not going to get you all the way there. I wouldn't say it's wrong, because having data is better than not having data. But at the same time, having data and having no expertise and no way to analyze it is kind of marginally better than not having the data. In light of this, if you haven't mastered Excel and SQL, you probably shouldn't attempt to do more advanced statistical analysis, and then I will have another point about this. So small data analysis is where you practice before you go to the big scale. We get plenty of calls around using commercial tools, whether it's IDS, IPS, SIM, log management, whatever else. And some people say, you know what, I think it's too hard to write my own IDS, IPS signatures. Or I think it's too hard for me to write my own correlation rules or write my own reports. Or I have to know SQL to do X, Y, and Z. For these people, obviously, mastering the tools they have and figuring out how to maybe profile users, how to load additional type of data, and then analyze it in the tools they have is the route they need to take before they go to any kind of a custom-built system. Yeah. Sure, go ahead. Mm-hmm.
Sorry. Just want to make a quick announcement. Did anyone here in this room bring a dog with them to the dojo today? Because if you did, dogs aren't allowed, and there's a dog trapped in a room. So we're trying to figure out whose it is. So
that's a good one.
In that room, one
Okay.
announcement here.
The dog? Oh, that's a good
Okay.
tiny dog.
Anyway, sorry.
No, that's okay. Look for small data. Okay. But do search for the dog. We need to search. Type dog. Yeah. It should be easier than finding a needle in a haystack or even a needle in the needle stack or whatever. So here's another bit that emerged from this research, is that a lot of companies, well, these two approaches, which come out from other research around big data analytics, not connected to security, emerged in other domains. And I've seen them being used for our domain, information security. Specifically, I have this IP address. What do I know about this? I need to have a system that tells me everything from my own history, from external context, threat intelligence. So this is kind of based on a particular clue I have, or based on a particular goal. I need to know which users are uploading files to whatever system. In essence, you can start from goals. But some of the successful projects also start from trying to visualize, explore, reduce the data, and then converge it to conclusions. Now, the first one is obviously more likely to converge at something more useful, but we have seen organizations that sort of say, here's the data I have. Let me apply my analytic expertise, let me apply my mindset that I mentioned to figure out what it means. By the way, none of these two say, start from collecting as much as possible. And that's a major point here. You guys are probably not controlling that much budget in terms of buying stuff, but it's a useful point to make to your boss or your boss's boss or to whoever. At this stage, there's nothing much to buy. There's no boxed tool that would give that for you. And then there's obviously a point about resources. Some of the things in my past life when I was at vendors, I was doing a lot of analysis of the data in the SQL database of the SIM vendor that I worked for. Now, I was surprised to find out that SQL expertise, and it was 7, 8 years ago, wasn't that prominent among network security analysts. It probably isn't the case, probably still the case now. So the logic here is that these type of approaches, this type of systems require even more expertise. It isn't not about SQL, it's about other types of data access methods. However, the organizations that did get to this big data type systems ended up having statisticians or researchers build data access tools usable by other people, which is interesting because it's hard to say, why wouldn't vendors do it? Why wouldn't vendors build the tools? But the point is that most of the successful projects and their algorithms ended up being very site-specific. So some people at the organization build the tools for others at the same organization to use to discover gems in the data, to data mine, to visualize. It wasn't done by the vendor because most of the algorithms were site-specific. Now, I probably did enough motivations or demotivations in this talk, but I wanted to still provide some guidance for what I would call truly adventurous, which stem from recommendations as well as the rest of the discussion. what data do you have and how you can use it, whether it's logs or something else. Starting with small data, if select star from something confuses you, you're probably not ready for MapReduce. Figuring out, start from a goal or a clue and find more context, figure out, or start from the data and try to summarize it. It's a useful decision to make. You obviously can go both. The whole approach of applying statistics and data mining and machine learning and other methods is new to a whole bunch of people. And so starting to learn the methods and the tools and picking at other domains. I've seen one organizations where network security engineers pretty much went to the team that dealt with web marketing and figured out how they analyze the data. And then eventually you might expand collection to the case where you will in fact be in big data land. But the path to big data for security success doesn't start from the bigness. It starts from the analysis and algorithms and approaches and the mindset, not to the size of the data. And then, yeah, well, that's final bit of demotivation. I guess I shouldn't be kicking the dog that much. I couldn't find the source for the quote, but I've heard it quoted plenty of times. So, but let me switch back to positive. Thanks a lot for your attention. Hopefully it wasn't too shallow for the room, but it did take some number of months to extract and summarize. So at least there's some insights there. Yep. Any questions? I think you guys go on.
So what I'm entering with this with big data is I have questions I'm asking the data, and now my data is too big, and I can no longer answer them, so it took big data. Have you talked to anyone who's been able to ask and answer new kinds of questions? So in other fields, that's what big data is used for. Is anyone actually able to ask new kinds of questions? Security big data.
Yes, but unfortunately, so yes, the answer is yes. However, after that yes, it would be nice if I can say how they did it. Unfortunately, that I cannot do. Here's the reason. They did it by asking more and more questions, and with every answer they got, they sort of became a little bit more data-driven and started thinking about better questions. So this, in the paper that this is based on, there's this whole life cycle from trying to use data, asking some basic questions, getting useful answers, becoming more data-driven, collecting more data, and the whole thing kind of, after they went through this iteration a couple dozen times, they got to questions they never thought about up front. So this, the iterative part, is basically what made the magic happen, not any particular algorithm. I mean, I was kind of harassing some of the people who do this with which algorithm you used, unsupervised learning or clustering or principal component analysis, give me the right algorithm. And they all pretty much turned my head back to the mindset, and they're like, no. This algorithms work here for this domain, for this type of data, in this type of circumstances. There is no one algorithm to use. And to me that was kind of sad, but because it's much easier for me to give guidance on algorithms than on creating the mindset. Yet this is what I'm stuck with. Yep.
This is kind of a follow-up question. Can you give some specific examples of where there have been successful projects, what they've done that's been great? Like in this company, they saw this thing they hadn't seen before. In this company, they had a new system that's helpful this way.
Okay.
What's the benefit?
So let me try to obscure some of the details and so that it's still useful. So one company did a lot of with flow analysis because they had flow going into net flow going into collectors, but they weren't doing much. They were only using it for incident response. Over time, they started figuring out whether they can profile the behaviors, whether they can do the slightly more proactive type of analysis as opposed to just search in case of an incident. So because their volumes are so high and their network is so complex and distributed, the volume of flow data was, I think, in low terabytes per day. So as a result, they got to a system which highlights certain behaviors before they're obvious from other means. This is one. Another company did a lot of stuff around web proxy logs and profiling user behavior to identify compromised boxes. They fused proxy data with context, domains visited, information, the information about the websites, type of content downloaded, and then they actually machine learned the types of behaviors which are associated with compromised boxes. And then they were able to proactively say, the system runs overnight, and then in the morning they say, these 3 boxes are very likely to be owned. Go look at them. So this was the web proxy use case. Another one was actually on the web server side. It was like an e-commerce company that wanted to do a profile of the visitors to see which ones are more likely to commit either fraud or use stolen cards. So they had to fuse plenty of data, threat intel, web server logs, backend application logs, and then come up with the answers. This user is this much risk, this user is this much risk. These are 3 examples that sort of pop out. Okay, yeah, give it.
Have you had much experience with Security Onion?
I know what it is, well, it's the
I found it
distro.
to be a really good tool for people who want to get their feet wet because it records packet traffic on the
Yep.
same port. It's very easy to set up. It has quite a large collection of
Tools, yeah.
in a central database, and it's all free software.
And it's also distributable. I like that you can do sensors and you can do single machine and do multiple machines. Yeah, I used it. Well, I've seen it quite a few times, and I used it in the past. So it's a good
Plus, it
system
has
to start.
a single database as the back end.
Yeah.
You know,
It's right. It's easier to extract stuff. Yeah. Yeah. Oh, sorry. Go ahead.
How many vendors and organizations did you look at to generalize?
We are talking about low dozens. So very very small number, and even those are very hard to find.
How big scale organizations or like including some smaller like
Nothing,
neighbors?
nothing even remotely small. I mean, some companies are small by employee count, but very large by data volume. Obviously, you can have an e-commerce company with that much employees and a retailer with this many employees, but they might have comparable data volumes. So all the companies are either large by employee count or very large by data volume count. There's nobody. We kind of call most of them the type A of type A. It's not just the top companies, but kind of the top of the top companies. Yep.
Have you encountered any good strategies for accelerating
Well, with some of these technologies, the cheaper choice was to not do it. And there was, I mean, I'm not a major fan of the infinite retention periods for any kind of data, but occasionally it's easier to not think about this, at least until you cannot expand anymore. And that's a surprising answer to me, because again, back in my RDBMS days, we always thought about 30-day retention policy, 90-day retention policy. Here, I've seen some people say, well, while it works, we're going to keep adding nodes to the cluster. And that's how they solve the problem.
What kind of stuff do these statisticians do that end up useful at the out end?
Mostly, that's kind of I don't have enough to summarize because they're all like bits and pieces here and there. But the one useful bit is probably the concept of the hypothesis testing that isn't very obvious as far as network security or data security is concerned. So the point is that if we assume that the user behaves in this and that way, can we test whether they really do? And whether this model of behavior for a compromised machine really manifests in reality. So that's probably the one bit from statistical thinking that ends up being more or less universally applicable. Everything else is very domain specific. And it will be useful here, but not useful there. It's kind of the half answer.
How do you get the ground set to compare the, I mean, you can't really tell when something is compromised all the time.
Well, but you'd want to, right? That's kind of the point is that there's no one way to discover the machine is compromised. But that's why it's so challenging. That's why in my organization might be this kind of signature behavior. In your organization, it's more like this one. Any more questions? I'm rather easy to find, so if you have additional questions, you can drop me an email. I don't think I have my email here, but I have the... Well, I'm easy to find. I'm easily Googleable. So if you have any questions, drop me an email. Thank you.